In our last video, we studied about central metal atom. What is a central metal atom? What is coordination entity or coordination sphere? We studied. Also, we studied about ligand. Based on the donor site, a ligand having. Ligands are classified into monodentate ligand, didentate ligand, tridentate ligand, that means mono, di and polydentate ligand. So ligands are further classified into chelate ligand. It is also classified into ambidentate ligand. Like there are so many different classification of ligands we studied. Also, we studied about tendency of a ligand. All these points we studied in our last video. Now, we are going to continue the terminology. In this video, we are going to discuss about three more things. That is, first one is coordination number. Coordination number. Coordination number means it is the number of chemical bond formed between the ligand and central metal atom in a coordination compound. What is coordination number? Number of chemical bond formed between the central metal atom and ligand. For example, consider a coordination number K4FeCN 6 times. In this compound, K4 is the outermost, that is counter ion. Fe is the central metal atom. We studied. How many cyano ligands are present? 6. So Cn, 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 Cn and Cn. So totally 1, 2, 3, 4, 5, 6. 6 chemical bonds are formed between the central metal atom and ligand. Therefore, the coordination number is equal to 6. Let us consider this complex CO, En, 3 plus. Do you know what is meant by En? En means ethylene diamine or ethane 1,2 diamine. It is a neutral ligand. Ethane 1,2 diamine is a didentate ligand. So, when there are COEN 3 times, this is the complex, 3 ligands are present. But listen here, CO, each En forms 2 bonds because it is a didentate ligand. Here another one En is present, it is connecting the central metal atom with 2 bonds. Here another one En is present, it is connecting the central metal atom with 2 bonds. That means number of chemical bond formed between the ligand and central metal atom is 1, 2, 3, 4, 5, 6. So coordination number equal to 6. CO OX thrice 3 minus. If you consider this complex, do you know what it means by OX? OX means it indicates C2O4 2 minus. The name of the ligand is oxalato. 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 Oxalato is another one didentate ligand. Here, the central metal atom is cobalt. How many oxalate ligands are present? 3. One OX is here, but one form 2 chemical bonds. Why? Because it is a didentate ligand. Another one OX is present, it forms 2 bonds. Another one OX is present, it forms 2 bonds. Totally 6 chemical bonds are formed between the central metal atom and ligand. Therefore, the coordination number is equal to 6. What do you mean by coordination number? Number of chemical bond formed between the central metal atom and ligand. Just consider this example. NiCl 4 times 2 minus. How many ligands are present? 4 ligands are present. So NiCl, Cl. So 1, 2, 3, 4. 4 bonds are formed. So the coordination number is equal to 4. Coordination polyhedron. Coordination polyhedron. It is the spatial arrangement of ligands around the central metal atom in a coordination entity. For example, consider this NiCl 4 times 2 minus. There are 4 ligands are present. How these 4 ligands are arranged? These ligands are arranged NiCl, Cl, Cl, Cl. So the structure of the complex is square planar. So the coordination polyhedron is square planar. Suppose if 6 ligands are present, for example in the case of K4, Fe, Cn 6 times. In this complex 6 ligands are present. How these 6 ligands are arranged? These 6 ligands are arranged Fe, Cn, 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 Cn. Then outside K4 is present. Then one Cn is present here, another one Cn is present here. The structure is octahedral structure. If the coordination number is 6, then the structure of the compound, then the coordination polyhedra is octahedral. If the coordination number is 4, then the coordination polyhedra is tetrahedral or square planar. The next one is oxidation number. That is oxidation number of the central metal atom. So oxidation number means it is the charge carried by the central atom when all the ligands are removed along with their electron pair. Oxidation number means it is the charge carried by the central metal atom when all the ligands are removed along with their electron pairs is called, that charge is called the oxidation number of the central metal atom. For example, consider this example CO NH3 6 times 3 plus. NH3 is the ligand. We are removing 6 NH3. NH3 is a neutral ligand. For neutral ligand, the charge is 0. So we are removing 6 neutral ligand out. So automatically the charge becomes 3 plus. So the oxidation number of central metal atom is plus 3. Similarly, if you are taking another example, CO Cl 4 times 3 minus. CO Cl 4 times 3 minus. So 4 Cl we are moving outside. So what happened? 4 minus 3. That means charge will become CO plus 1. Charge will become CO plus 1. Plus 1. The charge will become plus 1. So oxidation number means it is the charge carried out by the central metal atom when all the ligands are removed along with their electron pairs. The next terminology we have to study is homolytic and heterolyptic. Homolytic and heterolytic complexes. Consider this example: CO Cl 2 times Cn 2 times 3 minus. And also consider CO Cl 4 times 3 minus. What about these two complexes? The central metal atom is cobalt. The ligand is here Cl, here Cn and Cl. Here totally 4 ligands are present. Here also 4 ligands are present. For both the complex, the charge is 3 minus. Then what is the difference? Here the complex is surrounded by different types of ligand. Here the complex is surrounded by, the central metal atom is surrounded by same type of ligand. If a central metal atom is surrounded by same type of ligand, then the complex is called homolytic complex. If the central metal atom is surrounded by different types of ligand, then it is called heterolyptic complex. That's all about the terminology of Polyhedron complex.